All right, people, this is actually one of the four questions from last year's AP. They recommend 25 minutes, and the average was a 5.34 out of 10. So about a little bit over 50%. My sense is that the average will get you a 3, right? So you want to beat the average by I think, like by one standard deviation or whatever. You want to be at like a 7 or an 8, I would guess, to get a 5 on this. Okay, so there's a lot of reading. I'm assuming you read this already. So you be careful. They are wanting you to visualize the momentum, and so the momentum of block one, the default was two blocks, which so they're saying that since the momentum of this block is mass times velocity, I'm going to pull the two out front. They're saying, two blocks. So the one block is mv naught. So if you look at this momentum of block two, it's 6m times negative v naught. So we want a vector pointing to the left that is 3 times bigger than that. So you're going to start at 0 and you're going to go back 6. So I'm saying 6. I don't know if that is 6 or not. So that's the initial momentum before the collision. And then they were a system. So they're just now stuck together. So the momentum of the system, that's why they had you grab momentum and not velocity. The momentum is conserved. So you've got 6 to the left plus 2 to the right will give you 4 to the left. Okay, so you got a point for correctly saying that this was 6 to the left, and you got a point for adding those two vectors to find the total momentum. So if you understood what was going on in theory, I would say that was 3 points. Okay, and then there's a lot of words. So I'm going to talk through this a little bit. So there is some time interval of the collision, right? Remember when we talked about impulse, the force will squish and unsquish. The collision takes some finite amount of time. That's your time interval. And if you look at both blocks as a system, there's no outside forces. But if you isolate either of the two blocks, then there's a force, and they're representing the squishing and the unsquishing by saying, hey, it's a sine function that gets bigger and then smaller again because it's going to squish and unsquish. So that's what they're doing, except they're giving you a function. They're giving you a function. That means you're going to need to integrate or take the derivative. Okay, and then derive an expression for f max. And you might be confused because your brain is going to say, oh, how do I maximize a function? Take a derivative set equal to 0. We're talking about momentum. We're talking about the force between two objects. So it's a little bit confusing because what they want you to solve for is kind of in the middle of what we're looking at. So I'll say this kind of slowly. You want to pick one of the two blocks as your system, and they kind of didn't care which one, but I think they were leading you to block 2. So block 2 is the system. So you have M2, V2 initial, plus that other block is exerting an impulse on it. Boom, impulse is an integral. Equals M2 V2 final, right? So momentum isn't conserved if you isolate either one of the two blocks, only if you look at the system. So M2 had a mass, I'm dropping my unit. Nope, I'm not. It had a mass of 6m and an initial speed of minus v naught. Plus, we are going to integrate this force, F max sine of AT from 0 to TC is like T collision time, I guess. And that equals 6m times V final, which was minus 4/7 V naught. And you're like, how did I know that? As I was setting this up, I'm like, oh, I don't know what V2 final is. So I went back to this diagram and I conserve momentum. So super quickly, I said m times 2v naught plus 6m times, watch your minus signs, minus v naught equals, oh, they stick together, 7m v final. So that's v final for both blocks. And then you get minus 4/7 v naught. That's where that came from. Okay, so I don't want to forget to tell you where the points were. Saying, just understanding, like, this is a true fact. Like, momentum plus impulse equals momentum was worth 1 point. Let me do that in another color. That was worth 1 point. Depending on which block you defined as your system, you got another point for conserving momentum to find its final velocity. You got another point for correctly setting up the integral by knowing, oops, don't do what I see all the time. You have to put that dt in. So you had to go from 0 to the end of the collision time. You had to have a dt in there, but just setting up the integral was worth a point. Okay, so a point for understanding impulse and momentum, a point for knowing what the final speed was, a point for understanding that you have to integrate, and then all of this algebra that I'm going to do was just worth 1 point. So again, they're rewarding the ideas and the concepts and the relationships, not the algebra, but you still got to do the algebra. Okay, so I'm going to bring this over to the other side, integrate this, and be careful. I went on autopilot, and I didn't completely take the derivative, but I brought the a out instead of dividing by the a. Don't forget to evaluate. It's a definite integral. And then this turns into 6 mv naught from here, positive, minus, this is still negative, minus 24/7 mv naught. Okay, and then you can fast forward if you want. What we're just going to, we need to solve for f max. So again, it's weird that they're like, find f max, because it's inside here. And so it doesn't really, feel like you're finding a value, but it's kind of a work backwards problem. And then you got to evaluate f max. Oh, so do the f max over a, evaluated negative cosine of ATC minus a minus, right? We're doing the upper limit minus the lower limit, so minus the minus turns out to be positive. F max over a, cosine of 0 is 1. So just don't assume that your lower limit, you plug in 0 and you get 0. That's only true for polynomials. Equals 18/7 mv naught. And then we're going to factor out the f max and then solve for f max. And again, this is not the physics part. Just don't be surprised if you do have some algebra to do. And then this reduces to, because there's a minus sign here and a plus sign there, so it's 1 minus cosine of ATC. But all of this stuff is only worth 1 point. Okay. Again, the important thing is to revisit momentum plus impulse equals momentum, and impulse can be an integral. Okay. Oh, and then I'm like, there's one more question, I know. Okay, so that was all 2. And again, derive does not necessarily, derive just means show your work. It doesn't mean like you have to start with f max equals. So I don't like the word derive. But so just derive just means understand all the relationships, solve for what you don't know. Okay, I had to think about B a little bit. Then this is the last part of this question. So block 1 initially slides, I had to draw a new picture, in the positive x direction with a new speed v1, and block 2 initially slides in the negative direction with constant speed v naught. They collide and stick, but then they have a constant speed of v naught. I'm like, how can that possibly be? Because this one already, I'm like, that must be a typo, and I looked it up. So I think what they're trying to get you to realize is and I had to draw a picture. So this is your before picture. And they stick together, so you know this. There's no way they can continue forward with a speed of v naught, right? This guy's going to be slowed down. What that means is this speed was so big because this has much less inertia. V1 must have been massive, so that what it did was it pushed both of them in the end to the right with a speed equal in magnitude to this incoming speed. So I'm not sure what the point of all of that was, because again, I'm like, that can't be right. That has to be a typo. There must have been some number in front of that v naught that I missed. So unless they were wanting you to really realize, oh, well, that's just speed, they can change direction, which is, helpful, but I mean, makes you think about the world. But on an AP, when you're like, rushing for time, you're not always going to have that insight of like, oh, it could have changed direction. Okay, so anyway, then once you realize that, it's just again, show your work. Sum of the momentum equals sum of the momentum. So mv1 minus 6m v naught equals, they stick together, 7m v naught. Okay, I'm putting the minus signs in, so all the v naughts are the same in magnitude. And so you can do the algebra. You get v1 equals 13 v naught. So again, it was an interesting puzzle, but was a little bit frustrated that it took me so long to read it carefully. This was worth a point. So just saying momentum is conserved, throw those concepts down. Those are worth points. That's a 1 point. Applying everything correctly, with plus and minus signs, that's worth a point. And then getting your final answer was worth 1 point. Okay, but just stating momentum is conserved for the system is 1/3 of those points. So that is again a real question from last year on momentum. So again, the average, there was 10 total points. Hope that you figured out where they all were, and the average was 5.34.